Hello everyone and welcome to this video on meat traceability and authenticity. My name is Karen and today I'll be taking you through the critical importance of safeguarding integrity and consumer trust in the modern meat supply chain. By the end of this presentation, you'll understand how traceability systems and authenticity checks protect both consumers and producers while ensuring transparency across the entire meat industry. The meat industry is one of the most complex supply chains in the food sector. From farms to consumers, every stage has its own risks and challenges. It begins with farmers and livestock breeders, where animal husbandry, feeding practices, and health monitoring take place. Next are slaughterhouses, responsible for processing, carcass management, and the first quality checks. The meat then moves to processors for cutting, packaging, and sometimes value-added processing before reaching distributors who manage cold chains and logistics. Finally, retailers store and display the products before they reach the consumers. At every handover, there are risks of contamination, fraud, or quality loss. That's why rigorous documentation and quality assurance protocols are essential to protect food integrity. Before we dive into meat traceability and authentication, we need to understand the real problem: meat fraud, which unfortunately is one of the biggest threats to the meat supply chain. Meat fraud includes deliberate mislabeling, substitution, dilution, or false marketing for profit. Examples include species substitution, like the 2013 European horse meat scandal, where horse meat was sold as beef. Another is undisclosed additives, where water, starch, or soy protein are added without proper labeling. There's also origin misrepresentation, when products falsely claim to be organic, grass-fed, or locally sourced. And finally, unlabeled mixing of different meats. Beyond financial damage, fraud shakes consumer confidence and in some cases compromises food safety. So what exactly is meat traceability? Simply put, it's the ability to track and trace meat products throughout the supply chain, from farm to fork. There are two main types of meat traceability: internal and external traceability. Internal traceability monitors processes within a facility like slaughtering, deboning, and packaging. On the other hand, external traceability follows the product across the entire chain from farmers to retailers and ensures an unbroken record. Key data collected includes animal origin, species and breed, batch identification, processing timelines, packaging details, and distribution records. Together, this creates a digital footprint for each product, making recalls or investigations much faster and more accurate. So, traceability isn't just about safety. It ensures consistent quality assurance, verifies ethical sourcing and animal welfare standards, and promotes sustainable farming. It also protects producers from unfair competition while building consumer confidence. In short, it strengthens the entire food ecosystem. Now, how is traceability achieved? Modern systems use technology at every step. Barcoding and QR codes store essential information like origin and batch numbers. RFID tags allow real-time wireless tracking. GPS and geolocation tools ensure products come from the claimed region, and IoT devices monitor temperature and freshness in the cold chain. Together, these create an unbroken chain of custody, giving full visibility and enabling rapid responses to safety issues. Coming to meat authenticity. Authenticity verifies species identity, geographical origin, production methods like organic or antibiotic free, ingredient lists, and even religious certifications such as halal or kosher. So basically, traceability ensures where meat comes from, while authenticity ensures what the meat really is. This is where advanced testing and verification methods come into play. Let's explore those now. There are three primary scientific approaches to verifying authenticity: DNA-based, protein-based, and spectroscopic methods. First, DNA-based methods. These are considered the gold standards. Techniques like PCR amplify DNA sequences to detect species. Variants like qPCR allow quantification, while multiplex PCR can identify multiple species in a single test. DNA barcoding compares sequences like the mitochondrial CO1 gene against global databases to identify unknown meats. The next generation sequencing, or NGS, can reveal multiple species in highly processed or mixed products, giving a comprehensive analysis. Second, protein-based methods. Here, scientists examine unique protein signatures. ELISA, for example, uses antibodies to quickly detect species-specific proteins. It's affordable and practical, though less precise than DNA. For higher accuracy, mass spectrometry methods like MALDI-TOF and liquid chromatography with tandem mass spectrometry create protein fingerprints even in cooked or processed samples. Third, spectroscopic methods. These are rapid and non-destructive. Near infrared and mid infrared spectroscopy identify meat composition through molecular vibrations. Nuclear magnetic resonance, or NMR, provide a detailed molecular fingerprint, useful for detecting subtle adulteration. Increasingly, these methods are combined with chemometrics and machine learning, which improve accuracy and reduce false positives. Together, these scientific tools form a powerful defense against fraud. Now, even with advanced science, real world implementation isn't always smooth. The first problem faced is fragmented supply chains. Many developing regions have local butchers, small farms, and informal markets. Without cold chain infrastructure and digital record keeping, tracking meat is extremely difficult. Second, limited technology adoption. Tools like RFID or blockchain may work in large commercial systems but are costly for small scale producers. Advanced lab tests are also too expensive for routine screening. Third, regulatory gaps. Overlapping responsibility between food safety, livestock, and animal welfare agencies often create weak enforcement. Then come socioeconomic barriers. Consumers, especially in rural or low income markets, often prioritize price over quality. Awareness of meat fraud is low, and willingness to pay more for authenticated meat is limited. For producers, the cost of implementing advanced traceability often outweigh perceived benefits, especially when no direct financial incentives are provided. Finally, processing challenges. Once meat is minced or cooked, visual identification is impossible. This makes scientific methods like DNA or protein analysis essential but also more costly. All of these challenges mean that while science has advanced, scaling these solutions across diverse markets remains complex. Now let's look at a real case study that highlights these issues. In 2021, in Uttar Pradesh, India, consumers filed complaints about suspicious meats being sold as goat. Because goat meat is significantly more expensive than buffalo meat, fraudsters had strong economic incentives to substitute it. When authorities investigated, FSSAI laboratories used DNA barcoding of the mitochondrial cytochrome B gene along with PCR assays and ELISA screening. The results were alarming. Over 40% of the samples tested positive for buffalo DNA, even though they were labeled and sold as goat meat. This wasn't just about economics. Such mislabeling has serious cultural and religious implications in India, where the type of meat consumed can be extremely sensitive. The case led to enforcement action such as shop closures, mandatory implementation of traceability systems, and formal notices under the Food Safety and Standards Regulations. This example clearly shows how science, through DNA based methods, can uncover fraud, but it also illustrates the difficulty of enforcement in fragmented, price sensitive markets where oversight is limited. In India, meat regulation involves multiple authorities. The FSSAI sets safety and labeling standards, DAHD focuses on animal health and traceability, and APIDA manages export certification. Religious and standards bodies handle halal, kosher, and BIS compliance. But coordination between these agencies is often slow, which weakens enforcement. In conclusion, meat traceability and authenticity are critical pillars for food safety and consumer trust. From QR codes and RFID tags to DNA barcoding and blockchain, technology is giving us powerful tools. But success depends on more than science. It requires education, regulation, affordability, and collaboration across the supply chain. With stronger traceability and authenticity systems, we can ensure not just safer food, but also more ethical, sustainable, and trusted meat industries worldwide. Thank you for watching.